Cool. Hi, guys. Thanks for coming today. It's really exciting to be able to speak here because there's so many open minds and hunger for something new and something practical. So I'm going to go through a 15-minute journey of what Huxley is and what we're doing, what our mission is, and how I'll connect with people in this room. So I'm going to start out with a little video. About 3 months ago, I was in Milan for Seeds and Chips, and this was a video we produced for before Obama's speech in Milan. And basically, this video was to hype up the whole audience, to get them excited about vertical farming, urban farming. And what was really interesting is that Obama, after 8 years, realized that agriculture is the thing we can actually disrupt that will create the most good in the world. And these are renderings of what cities can look like. If we can move our food closer to us, we have less transportation, less CO2 emissions. And so by bringing our produce into our cities, we're able to stave off climate change, desertification, feed people healthier food. Everything about this is beautiful, delicious, and what we need to do. So it goes from architecture, edible architecture, to the medicines, the plants. We don't need to grow it halfway around the world anymore. We can grow it here. And we can grow it here now because of artificial intelligence and augmented reality. So Dixon de Pommier, who invented the term vertical farming, he says that if we bring 10% of the plants we eat into the cities we love, that would absorb enough carbon dioxide to bring CO2 levels back to 1980s standards. Also, what is important is that we need to produce 70% more food for an additional 2.3 billion people by 2050, and we're already maxing out horizontally. So like I said, the president gets it, Sam Cass gets it, his chef. And essentially what this is called is climate adaptation. You know, we're trying to remediate it. It's going to take some time. We have low, medium, and high goals of where we should go for climate change. But adaptation is better because instead of relying on or guessing what the weather is, now you have smart greenhouses, now you have vertical farms. As the weather gets more volatile, you want to have controlled environments. The nice thing is that hydroponics and air, light, water variables, and it's very complex field. And within the next 10 years, we're going to have AI that's smarter than humans, that can watch over all of this. It's a mega trend. What you're seeing here is Arrow Farms in New Jersey growing enough food for southern Manhattan. It's all over the news. The things that the vertical farms don't have yet is computer vision. So Huxley is creating artificial intelligence with computer vision. When you look at a plant under infrared, you can actually detect diseases 3 to 4 days before the actual human eye can see it. So this is why you put cameras in the greenhouse, and you can save about 5 to 10% of the crop. Now, when people make apps for farming, it's on an iPad or iPhone. And when I've been a farmer for the past 3 years, and you want your hands free. So we're creating an augmented operating system called Huxley to enhance the labor so that they can move through the greenhouses 2 to 3 times faster. This is about 25% of the operations budget. And we believe that we can reduce those costs so that urban farming is economically viable. There's just very few companies in the world right now that are economically viable, and labor is the labor economics is what we're aiming to crack. So you can apply this to the consumer unit that's on your kitchen table. You can have the camera in the AVA unit with the environmental control. This becomes a global decentralized science experiment. The plant cube, more controlled cameras also. This is a company based out of Munich called Agrilution. This is InFarm in Berlin, and their produce is supposed to be a lower cost than conventional farming, soil-based farming. And then you have vertically integrated, where you have a greenhouse on top of a Whole Foods. This is Gotham Greens in the Gowanus Canal. Then you look at AeroFarms in New Jersey, and it's like the matrix for plants, right? You just have this, 100 acres inside of 1 acre of vertical farming. Now, the beautiful thing about this is once these systems are set up and you know where they are and what plants are in there and you're using AI, now you have a macro AI. So the micro AI now becomes macro, and it's seeing all these plants. It's knowing what the genetics are of each plant and their optimal yield. So if you think this is easy, if you think it's easy to connect a farm that's been doing this for 10 years and has all their data, and another unit that wants to keep their data, how do you incentivize that? What we're working on is a dot plant, which is a blockchain protocol to connect all these devices, from the home unit to the prosumer to the enterprise level. And they can all learn and they can all share optimal environmental recipes. So without the AI, you don't have the AR. Without the AR, you don't have the blockchain and the AI. The blockchain becomes the DNA of how Huxley learns, and then the incentivization for the farmers to essentially mine the plant data. This is the first blockchain instance outside of traditional fintech or other blockchain applications. So with AI, AR, and blockchain, now we can crack the labor economics of urban farming. And this is what it looks like. So you can see up here, we have the air, the pH, the water. With the AR, you can literally walk through this facility. We're developing a Bluetooth beacon that you can attach any sensor to and throw it in 3D space and get a reading from that. So you can imagine, to make this a reality, there's a lot of different parts. But as we're creating the Internet of Food, this is what it starts to look like. So you can see my excitement. This is a greenhouse in the south of the Netherlands. Rijkswaan is a seed company. They're the second largest. And I was so excited to learn that their agronomists were the ones that developed the lettuce seed for the International Space Station. And when you look at this greenhouse, this is 108 varieties of tomatoes being tested at their research facility. And about 3,000 farmers around the world come in every year, taste their favorite tomatoes, and then this greenhouse is just, the seeds are distributed to the whole world. So I thank you very much for listening, and please share and join in the mission, because it's going to be a really fun and wild ride. Thank you.
Does anyone have any questions? All right, catch it and then speak into it. Catch.
Here?
Yeah.
Here?
Yes. Exactly.
Thank you for your talk. It was really interesting. But one slide that caught my attention was the second or the third, where you said that we need to increase the output of the food production by 70% to accommodate the 2.3 billion, I think, new people by 2050. And my question is, don't you think that in a world where 70% of, for example, the wheat and grain we produce goes to feed animals and 65% of the water, maybe the answer is to change the way, instead of increasing the output, we need to change the way we use our resources. So my question is, do you think we need to find a different solution like yours, which is interesting in many ways, not just this, but because people just won't change their habits, or there is something else?
Yeah, it's really hard to change people's habits. And then even if you change some people's habits, there's other people that have new habits and they want to eat beef and things like that too. Myself as a meat eater, meat and plant eater, I've realized that when there are better vegetables around and fresher and tastier, I don't need meat. I live in the United States. To find good vegetables, it's like New York or San Francisco. So the more good, efficient vegetables we can create will sway people to eat that because it's delicious, and they'll eat less meat. So I think it's, and then people should eat less beef, that's 12x chickens, so if you're gonna cut back on red meat. And yeah, it's a double-edged sword, but we add 82 million people to the planet every year. So I think that there needs to be a exponential solution to this that will sway people faster.
One last question. You could throw it up. Just throw it.
Hi, great talk, by the way. A very fascinating product. Do you think it might, the artificial intelligence aspect of it, would it extend to genetic manipulation and getting on a fast track rather than doing a lot of experimentation, but actually emulate manipulation of produce and make it optimal for the changing environments that you were talking about?
Yeah, I think what's really interesting, I like to joke that instead of a GMO, you now have an EMO, like an environmentally modified organism. And think about Saudi Arabia 2050. And you got 100 food computers, and they're all stressing the plants every 30 days in different iterations. You're A/B testing, 100 different plants at once with the same phenotype, and you stress it to the 2050 conditions, and one of 100 is going to have a good yield and good flavor that you can plant in 30 years. So I think AI is going to enable a rapid kind of phenotyping, and then there's some people that could do CRISPR that create a genetic that's optimal. But Reich Schwann is just hybridizing the seeds for the International Space Station. So it doesn't need to be too fancy. It's just more about the relationship between the phenotype and the environment of it.
Okay.
Yeah.
Yes. Thanks.
So that would be all of our time for questions. Thank you very much. Everyone give a hand clap.
Thank you.